You know, our planet's history is just packed with these huge, catastrophic events. Things so powerful they literally reshaped the world. But what if I told you the stories of those events aren't lost? They're actually written down, preserved in this incredible library where all the books are made of stone. So come on, let's dive in and become geological detectives. So, here's the big question, right? Imagine you're at a crime scene. Except the crime happened, maybe a few thousand years before anyone was around to see it. You've got no witnesses, no records, nothing. So how on earth do you solve a case like that?
Well, the answer, and this is where it gets really cool, is that the Earth keeps its own meticulous records. Every single massive storm, every devastating tsunami, it leaves behind a unique fingerprint, like a distinct layer of sand and mud. And if you learn how to read these layers, you can piece together what happened with amazing accuracy.
Okay, so in our geological crime scene, we've usually got two main suspects when it comes to these chaotic layers of sediment you find on old coastlines. Suspect number one, massive storms, think hurricanes. And suspect number two, tsunamis. Now, at first glance, they might seem pretty similar, but trust me, their methods, their signatures are totally different.
So let's meet suspect number one, the tempestite. The name literally comes from the word tempest, a violent windy storm. And that's exactly what this is. It's the geological signature left behind by an ancient hurricane or a massive cyclone, just a layer of sediment that got churned up and then dumped by the storm's incredible energy.
And our second suspect is the tsunamite. And yeah, you guessed it. This is the deposit left by a tsunami. Now, the key difference here is the cause. A storm is an atmospheric event, right? Wind and rain. But a tsunami, that's a wave, usually triggered by something huge, like an underwater earthquake. It carries a completely different kind of energy, a different kind of punch.
So, to tell these two apart, we need to look for forensic evidence in the rock. And one of the most important clues, the real smoking gun for geologists, is a super specific pattern called hummocky cross-stratification.
Now, this HCS thing, it isn't just a random pile of sand. It's a really distinct pattern of these wavy, mound-like layers, or hummocks. And they have these very specific, gentle slopes. We're talking usually no more than 10 or 15 degrees. In Italian sedimentology, they have this beautiful name for it. Stratificazione incrociata gibbosa. Just sounds cool, right? So how does this pattern even form? Well, think of it in 3 steps. First, a giant storm kicks up these enormous waves and currents that just scour the seafloor. Then, and this is the most important part, as the storm starts to die down, all that sediment it kicked up begins to settle. But it doesn't just fall flat. It settles into these signature hummocky mounds, basically locking the storm's fingerprint into the rock record forever.
All right, enough theory. Let's put on our detective hats and head out into the field, because this is where we see how it all works in the real world. We're going to check out a couple of case studies where geologists totally cracked the case. First stop, the Bahamas. And this is the perfect place to start, because if you want to study tempestites, you go to a hurricane hotspot. This lets us check our work, because we can compare the layers we find in the rock to storms that we actually have records for. And this is just brilliant. This shows the power of stratigraphy. On Caicos Island, researchers pulled a sediment core, and in just 30 centimeters of deposits, they could clearly see individual tempestite layers. And get this, they could match them to specific documented hurricanes. Donna in 1960, Betsy in 65, Kate in 85. This is huge because if we can read recent history in the rocks, it gives us the confidence to interpret the really ancient ones. Okay, so that was our storm. Now let's head to our next crime scene to see a completely different kind of culprit in action. We're off to the eastern coast of New Zealand's South Island, where geologists found evidence of a totally different kind of catastrophe. Over here, the investigation didn't point to a storm. All the evidence pointed to a massive earthquake back in the early 1900s. That quake set off a monster tsunami, which left behind a classic tsunami night deposit. It's like a geological scar from one single, incredibly high-energy event, and it looks completely different from those storm layers we saw back in the Bahamas. So, we've seen the evidence from our two very different case files. We have the tempestite from the storm, and we have the tsunamiite from the giant wave. Now it's time for the final verdict. Let's bring all the clues together and lay out exactly how you tell one from the other. Think of this table as our forensic toolkit. There are a few key giveaways. For one, scale.
Tsunamis can cover these vast areas, while tempestites tend to be a bit more localized. But for me, the real smoking gun is the basal surface, the bottom of the layer. A tsunami is so powerful it scours the seabed, leaving the sharp, clean scar. Storm deposits are usually a bit gentler at the base. Plus, tsunamis are much better at dragging stuff from the land, like trees and plants, way out into the sea. So you might be thinking, okay, this geological detective work is cool, but why does it really matter today? Well, it's about so much more than just solving ancient mysteries. It's about understanding the world we live in right now, and the one our kids will live in.
Here's the crucial point. The rock record gives us a timeline that stretches back thousands, even millions of years. Our written history is just a tiny blink of an eye compared to that. By studying these tempestites and tsunamiites, we can understand the true frequency of these major disasters, helping us create way better hazard maps and build much safer communities along our coasts. When you learn to read the rocks, you start to understand the real rhythms and risks of our planet on a scale that's so much bigger than human memory. It really makes you wonder, doesn't it? What other stories, what other absolutely crucial warnings about our future are still waiting to be discovered, locked away in the ancient stone right beneath our feet?